Hi, good morning guys. In this video, we will talk about a sequence. Sequence ordered list of numbers. A sequence can be finite or infinite. When we say finite, sequence, it has a limited number of terms. For example, 1, 2, 3, 4, and 5. As you can see, the sequence ended as 5 as its last term, and that is finite. Meanwhile, we also have infinite sequence. By looking at the word infinite, we can say that an infinite sequence have an infinite number of terms. For example, 1, 2, 3, 4, 5, and so on. What you can see here is that the sequence has an ellipsis, and that ellipsis or 3 dots indicates that the sequence goes to infinity. We have two common type of infinite sequence: the arithmetic sequence and the geometric sequence. Arithmetic sequence pertains to a sequence which has a common difference added to a previous. For example, 5, 9, 13, and then 17. If we minus the second term and the first term, we will get the common difference like this. 9 minus 5 is equals to 4. And same to the third term, 13 minus 9 is also 4. And as you can see, their common difference is 4. That's what we call the arithmetic sequence. Next is we have geometric sequence. It is a sequence that has common ratio multiplied to the previous term to get the next term. For example, 3, 9, 27, and then 81. So, the common ratio for this is 3. Since if we multiply each term by 3, we get the next term of the sequence. For example, we have the first term 3. We have the first term 3. We multiply it by 3 as their common ratio. 3 times 3 is equals to 9. So, and for the third term, we also multiply the second term for their common ratio as 3. So we get 27. And that's the introduction of finite and infinite sequence.
Hi guys, I'm Jerkim Haya, and this is the continuation of Sinley's discussion. Right. We can express infinite sequence as one of the two ways. Okay? We have the recurrence relation, which define each term based on the previous term. Again, based on previous term. And then, explicit formula can be defined each term as an equals to fn. For the given example by Mr. Sinley earlier, we have the arithmetic sequence 5, 9, 13, 17. So, sulat na ako guys. And the D is equal to 4. D stands for common difference. Okay. We can express it through first recurrence, so A sub 1 is equal to 5. So 5 siya, kaya mo na siya first term na siya, no? An is equal to an plus 4. So kaning 4 gikan na siya direct sa common difference. Okay. Since recurrence relation just based on the previous term. Since Since recurrence relation just base each term on a previous term, we can just input the previous term to the formula an is equal to an plus 4 to get the next term. For example, we get since recurrence relation just base each term on the previous term, we can just input the previous term to the formula an is equal to an plus 4 to get the next term. For example, we get the second term using recurrence relation. A sub 2, the previous term of the second term, we have 5. So, moment siya ang second term. So, ang previous term niya is 5. Diba? Alright. Plus common difference, which is 4. Common difference is 4, right? So, okay, to get the second term, we write a sub 2 is equal to 5 plus 4. So 5 here is the previous term of the second term, which is 5. Then plus 4, the common difference is equal to 9. Moving forward, the explicit formula of arithmetic sequence is an is equal to b times the quantity of n minus 1 plus a sub 1. So, since ang atong d is 4, so ang ato, no? an is equal to 4 times the quantity of n. So, ang n na to, n minus 1 plus 5. So, 5, mo na siya ang first term, di ba? Okay, so mo na siya. Moving forward on the limit of sequence. Since sequence are functions, it has also a limits. So, what is infinite term? If the limit of a sub n as n approaches to infinity is equal to L, sequence approaching L as n become large, then the sequence is convergent. If the limit of a sub n approaches to infinity does not approach a value L, it is called divergent. Okay, so mo na siya ang first example na no, sa limit of sequence. So an is equal to 1 minus quantity of 1/2 raised to n. Alright, so para makuha ang limit, so yung ano siya, no? The limit of 1 minus quantity of 1/2 the power of n as n approaches to infinity. Alright, so ato siyang isolve, no? Then 1 minus 0 equals to 1. So 1 is converges, di ba? Converges. Okay, so nganong converges siya, no? So as n become larger, kung ato siyang i-substitute diri so i-try niyo sa calculator, approaches to 0 din na siya, no? So 0. So 1 minus 0 is equal to 1. Means nga converges siya. Kay nag-approach siya certain value, which is 1. Right? Alright. Okay, so mo ni siya ang atong second example. Alright? an is equal to 1 plus 4n. So, para makuha ang limit, so yun yan siya, no? The limit of 1 plus 4n as n approaches to infinity. So, ato siyang isolve, no? 1 plus 4 times infinity is equal to infinity. So, kung infinity siya, it means nga diverges. diverges. So nganong makaingon tag diverges? Kay kung mag-substitute tag value diri so mag-approaches tag infinity. No? Kumbaga dili nato makuha ang certain value. No, mag-result siya infinity. So maong diverges siya. Right?
Hello, I'm Janiel Angteg, and in this portion we're gonna tackle the infinite series. So first, we are going to describe the differences of a sequence and a series. So a sequence is just only the terms, but in series, just like this, a sub 1 and a sub 2 and a sub 3. But in series, we are going to add the terms, and that is series as we get the sum. Just like I said earlier, that we are going to get the sums of the sequences. So we have here an explicit formula of n squared. So we have here the sequences which are 1, 2, 3, and 4. So to get the s sub 1 is we are going to square the first term, which is 1. So 1 squared is 1. So to get the s sub 2 is we are going to get the first two terms which are 1 and 1 squared and 2 squared. So first we are going to copy that we have already done the s sub 1. So and we are going to get the square of the second term. So 2 raised to 2 is 4. So, to add the square of the first two terms, 1 plus 4 is equals to 5. To get the s sub 3 is we are going to copy the results inside s sub 1 and s sub 2. I know the square of the terms. S sub 1 is 1, S sub 2 is 4, and S sub 4, no, then the square of the third term is 9. So 1 plus 4, 5 plus 9 is equals to 14. So now let's proceed to the S sub 4. Just copy this one, this first 3 squared of the sequences. Copy 1 plus 4 plus 9. Then the squared of the 4. So 4 squared is 16. So 1 plus 4 is 5. 5 plus 9, 14. 14 plus 16 is equals to 30. To get the partial sums, we have 1, then 5, 14, and 30. So, as we get the partial sums, does the series converges or diverges? So, partial sum of 1 is 1, S sub 1, then 2, 5, 3, 14, and 30. So, this series, we can say that it diverges because it does not approaches to the value L.
Hello guys, this is Kervin Sarusit, and what we are going to tackle in this tutorial video is all about divergence test. So let me give you a quick overview about divergence test. So divergence test is isa ni siya ka test para may bala na to if ang atong infinite series kay nag-diverge pa siya or wala. So even though kaning test kay dili siya maka-test
if ang isa ka infinite series kay nag-converge, pero it will definitely tell us kung ang isa ka series kay nag-diverge. So based sa iyang based sa iyang name nga divergence test, makatell siya if ang isa ka series kay mag-diverge. So okay, let's go to the presentation. So what we have here is the definition of divergence test now. So divergence test tell us if the limit of a sub n as n approaches to infinity is not equal to 0, then the infinite series as n goes from 1 to infinity of a sub n will diverge. So if ang limit sa a sub n kay dili mag-approach or dili siya mag-equal to 0, kay ang isa ka infinite series kay mag-diverge. So let me give you a example sa divergence test. Okay, what we have here, infinite series. So n squared plus 2n plus 1 all over 4n squared minus 14n minus 8. So to know if ang kaninga series kay nag-diverge ba siya, so we will find its limit. So the limit of n squared plus 2n plus 1 all over 4n squared minus 14n minus 8 as n approaches to infinity mo siyang magawas so kani nga situation we have the n squared as we have the 2 as the biggest exponent or the highest degree sa kaning nga series sa equation. So atong buhaton para makuha ang limit is we're just going to divide the numerator and the denominator by n squared. So okay, mo siyang dagway so n squared over n squared plus 2n over n squared plus 1 over n squared all over 4n squared divided by n squared minus 14n squared 14n over n squared minus 8 over n squared. So okay, para makuha na itong limit, ato nang i-cancel na yung mga same signs so n squared divided by n squared is equal to 1. Then 2n over n squared, cancel na itong isa ka n, cancel na itong squared, so may mo na siya 2 over n. Then as is na siya since wala n ang 1 all over 4n squared over n squared, since same lang ang n squared same lang ang exponent, cancel na to ang n squared. So ang mabili na lang 4, then 14n over n squared, ang mabili na kay 14 over n, then minus 8 as is na siya 8 over n squared. So as is kay wala n ang constant 8. So saan man siya karon, ingani siyang dagway. So if mag-substitute tag infinity sa mga n nga naa diri ang tahay kaning 2 over n, mag-substitute tag infinity. So ang result ana is 0, since if mas dako ang denominator number kay mag-approach siya 0 so you can try it in your calculator 2 divide 100 divide 1000, you will know that it will approach to 0. So may na siya gingana eh. So 1 plus 0, since ko og n ang sa ubos, so 0 plus 0 all over 4 minus 14 over n. So 0 gyapon siya, no? I-substitute natin infinity sa n. May magyapon 0, approach to 0. Then minus 8 over n squared. May magyapon siya 0. Same running mas taas. So, makuha natin siya. So, cancel natin mga 0. Hawakan natin 0. Then, atong limit is 1 over 4. So, based sa katong kuan na sa divergence test, since wala siya since dili siya equal to 0, then we can definitely say, as per divergence test rule, kaning 1/4 is not equal to 0, then we can say that this infinite series nag-diverge siya. Okay, so natin isa ka situation. So if ang limit of a sub n as n approaches to infinity is equal to 0, then ang atong infinite series kay mag-converge or diverges. So presa akong gingon nga ang kaning divergence test kay dili siya maka-test if ang isa ka series kay mag-converge, since based yan ang kaning divergence test is for divergence test okay. So I will give you an example nga ma-equate siya 0, no? So we have the series 1 over n squared, and then kuha na to yung limit. So 1 over n squared. So pila man ang 1 over n squared? So first atong gibuhat gain na atong i-substitute ang infinity sa n. So unsa may mahitabo pag mas dako ang ang denominator, as n becomes larger sa denominator, ang mahitabo kay mag-approach og 0. Then the answer here is 0. So kaning infinite series kay nag-converge or nag-diverge. So it basically says na kining divergence test is not enough to tell us if ang series kay nag-diverge ba siya or nag-converge. So that's all. Thank you. Sorry. Napaday. So, okay. Moto ang gingon nga ang kaning, since wala siya nagkuha siya sa rule sa divergence test nga dapat ang limit sa a sub n kay is not equal to 0, we can say that the infinite series converges or diverges. So para sa magiging gain dili siya, ang divergence test dili siya enough para makatel if ang isa ka infinite series kay, if kani nga series kay nag-converge ba siya or nag-diverge. That's all. Thank you.